Comprehensions in Python are arguably a little bit tricky to learn at first, especially if you're coming at this from a complete beginner. So what I want to do in this video is try and present a really interesting way of looking at comprehensions, and it's a way upon which you can basically break them down into three components, and this is effectively the same for list, set, generator comprehensions, and your dictionary comprehensions as well. Of course, there are going to be outliers. There's things like nested comprehensions. We can do if-else's inside these as well to make them a bit trickier. But the basic premise is that in a comprehension, we're kind of just doing three things and then sticking them together in this sort of sequence here. So the first thing we have is an action, which is, what am I doing with a piece of data? So are we squaring a number? Are we uppercasing a string? Are we passing to a function? The source is simply, where does the data come from? So if we had a list of strings and you wanted to go through and uppercase all of them, the source is just that list of strings. And the condition is of course optional. You don't have to do a condition, but say for example, we want to uppercase a list of strings. What if you wanted to uppercase only those that have a len greater than 4? Then that would be a condition. And we always do it in this structure here. We say, do some action for each item in a sequence, but only if some condition holds true. So let me just quickly bring up an example and show you a simple one. Suppose we had this list of numbers here, and you had a basic question which just said, can you square all numbers which are 10 and above? Now, my take on this is, if you're doing comprehensions for the very first time, is literally write it like this. So think about the thing you've been asked to do, and then try and identify where's the action. Well, in this case, the action's just square a number. The source is going to be for each number in this numbers list, and the condition is simply going to be if the number is 10 and above. So what I would do if I was writing this, if I can make a bit of space, is start off down here, and let's call this, let's see, square over 10. I'll try and do some at least nice variable names. So let's start off with our action. We want to square a number. So I want to do I star 2. You could just do I star I. There's two ways of squaring really, but this is fine. So we're doing this. Okay, so that's my action done. Now the source is, I want to do this for each number in the numbers list. So you could do I squared for each I in numbers. And that'll be okay up to this point. There's no condition yet. So say for example, if you were to go ahead and print this, this is just going to do this for every number. It's simply saying square something and do that for each thing in numbers. So it's going to go through all of this stuff here and just square it. So if we go ahead and run this, there we go, there's each number squared. So to put our condition on, we want to say, okay, now do this for each I in numbers, but only if that I is greater than or equal to 10. So now we're applying a condition to our comprehension, and we go ahead and run that. There we go. Doesn't matter if this is a generator expression, work the same way. There we go. It wouldn't matter if this was a set comprehension. It's still exactly the same. All we're doing is changing the brackets or parentheses or whatever. Dictionary ones are a bit different, of course, because we have to do a key and a value. But you know, you could do something like this. Let's see, we did I like that. That would work. So now we're saying the key is I, the value is I squared. So yeah, it's a small edit, but you know, it's marginal really, isn't it? So let's bring this back to a list comprehension. And really, I know this is a small example, but following this, I think, is a bulletproof way to really understand what comprehensions do and how to write them from scratch. So long as you, before writing them, try and translate it into this here, and then you can start by actually translating my action, my source, and then my condition. Just FYI as well, I do a full course on this on Udemy. I do actually do a beginner course, which has had just almost 1,000 people now. And I do a more kind of specific functional programming course. I really love functional programming, and comprehensions are of course a heavy theme of that. So feel free to check out the link in the description if you want to go take that course in full. Now for the rest of the video, I want to do a couple more examples and try and make them kind of more complex as we go on towards the end. So we'll do 3 more examples, and of course for each example we'll break it down into this first. We'll then translate our action source condition into an actual comprehension, and then we'll do a quick code review at the end. So let's clear the screen and kick off with our next example. Now the first of my 3 examples is as follows. So given this list of names here, I want to do the following. Uppercase all names longer than 4 characters, which contain no numbers. So of course, the first thing we've got to do is identify our action, our source, and our condition. And this one I think is fairly straightforward. So I'll just quickly get this written out here. Our action, source, and then our condition here. So the action in this case is just going to be to uppercase. So we're going to be using string.upper to do this. Our source is simply names. So we can just do for name in names here. And then our condition is arguably the most tricky part here. So longer than 4, which contain no numbers. So we're going to be wanting to use an if statement with an and stuck in the middle. So something like this, we could do, let's see, if len of name longer than 4 and name dot, we can use is alpha for this. There we go, just like that. Is alpha will only return true if this particular string contains only stuff in the alphabet, right? So you can have is alnum, which does numbers and letters as well, but yeah, this one will be fine for this. So now we have our action. In fact, let's go and do our action a bit better, how we want to do str to upper, just so we can be precise like this. So yeah, if I was doing this for the first time and I was a bit unsure, I would probably map them out like this here. So let's now redefine name, shall we? And just pass this in. So we'll do name dot upper. So here is my action, and I want to do name.upper for each name in names. Okay, and let's just actually print this first without the condition. So if I go ahead, print names, see, and there we go. Okay, so that looks good so far without the condition. And now all I got to do now is take this guy here. Bear in mind, like the only thing different in the if statement is that obviously there's no colon at the end. Your regular one will, so just ditch that colon at the end, and of course stick this in here. Of course, because I've used name and name, I'm going to be using name here as well. So let's see, so Charlotte is longer than 4, but has a 4 here, and Sarah is the same, will be name longer than 4, but has a 4, and then Ian, of course, that's not longer than 4. So let's run this again, and there we go, James and Michael. So again, just to recap, our action is uppercase a name. The source is do this for each name that appears in the names list, which is here. And we're only doing this if the length of that name is greater than 4 and that name is alpha. So it does that name only have letters inside it. Now I've done this one second because I think the logic of the action is actually a bit more complex, even though there's no condition here. So condition is gone. There's no condition in this case. Source is just for each num, so we could do num in numbers, something like that. Let's make that correct, shall we? For num in numbers here. Now we're actually going to use it. Now these look a bit like inline conditionals. So to show you what this is going to look like, let me show you with just like a single piece of data first. Suppose we had x equal to 6 here, and I will say y is equal to x to the 3, so x cubed, if x is even. So if I do x cubed, if x mod 2 is equal to 0, then we can do else x halved, like that. Yeah, quite a lot in one go, right? So feel free to pause if you want to go through that one. But let's just quickly print this and see what we get. 216, that's x to the 3. Let's try it. Let's try 10. So it should be 10 times 10 times 10 should be 1,000. Let's make this an odd number. So because it's odd, we're not going to be doing this one. We're going to be hitting the else. So we should be doing 7 divided by 2. We get 3.5. Cool. So grab all this. There's our action. So that's why I've done this one second, because I think this bit just warrants making it a bit more complex. So this is how you would do your if-else if you were in that situation. So let's build this up, shall we? We'll redefine numbers. And I'm just going to steal this just for quickness because I've already done it. And then rather than doing for num in numbers, we'll do for x in numbers here. If you did do for num in numbers, you end up with a name error or something like that because it doesn't know what num is. And then we can go ahead and print numbers and just check that this looks correct. So I think I'll start by clearing this and hitting this. So we can see the 10 is even, so that's cubed it. We've got the 4, it's also even, it's cubed that. The 7 is odd, so yes, go on ahead and half that as well. You could do floor division, so you could do the 2 slashes in here, and that would divide into a whole number and then round down. And there you go. So in a situation where we have an if-else, this is how you do it here. Arguably one I think takes a bit of practice, and I would suggest looking at inline conditionals first, or conditional expressions. It's kind of like Python's answer to the ternary operator. But yeah, it looks pretty cool when you can pull it off. Okay, let's check out number 3. Now this one's a bit more interesting because I want to kind of try and force using a function as the action part here. So what I've done for this one, it's a bit more of an outlandish question, and I know these are all novel examples, but I hope they try and prove this action source condition model can actually be useful. So for this one, we want to convert each string to a tuple of string bool, where bool represents whether it's a palindrome or not. Okay, so let me show you one example. Suppose we had, if I could take this, let's put this here, shall we? Let's say S is equal to race car here. So basically, the action will be convert S into something that looks like this. So we have the string itself. So, and I've not done the speech marks, that's okay. And because this is a palindrome, we want to basically give this here. So we're going from a list of strings to a list of tuples with the original string and then like true, false, true, false, true, false, according to whether this is a palindrome. So I want to do this by effectively making a function which returns this, and that then becomes our action. So we're going to be passing these to that function and then returning this in its place. So let me go ahead and build this out. I think I'll do this here actually. Let's just call this palin just for short. This takes in st, which I want to be a string here. And actually, let's do from typing import, let's do tuple here. I do quite like these typings, so let's make it look fancy, shall we? So this is going to be returning a tuple of string bool here like this. Okay, that looks pretty good. Now what we're going to do, let's see. So we want to return the st like this by itself, and then what I want to do here is do st is equal to st like this here. Now I know there's a multiple ways you could do this, but I want to kind of do this as a nice function to show how you would call a function inside this here. So to quickly show you what this would do, let's call this function, so we'll do palin of s. And I'm going to hit run to see if we get the right output. Race car and true, that looks good. Let's quickly make this a non-palindrome. Race cars and false. Cool, so that looks good. So let's see, our action now is going to be to do that function call. So palin, we'll do word here. The source is simply going to be something like this. So we'll do it can be for word in strings. So just pause there for a second. Action, call that function with something. And the source is going to be saying, okay, now you're doing this for each thing in here. And a condition, there's none for this in this case. But you know, if you wanted to do something like, okay, maybe for only strings that are a certain length, yeah, we can stick it in as a bonus. But for this question, it doesn't require a condition. So now we can go ahead and write it. So my strings is equal to, so call this function and pass in word. And then go ahead and do that for everything in this source. So palin word for word in strings here. So now when I print this, I would be expecting to see a list of tuples. Hopefully this has worked. So there we go. Microphone, false, race car, true, radar, true. Cool. Let's see. Suppose we wanted to kind of be type agnostic, then what we could do, you could convert it here. I suppose you could do st is equal to st dot lower. So maybe we convert it here like this. So let's go ahead and try that. Yeah, race car is still true. That's cool. And then suppose, for example, we wanted to then go a step further and say, actually, you want to do this for only strings, because if you did something like this here, this is going to go ahead and break it because you can't lowercase an integer. So we could do something like if is instance word string. So this is saying call this function with something, do this for each something in strings. So all of these here. I know this is now not a string, that's our anomaly. However, we can say only actually go ahead and do this if that thing is actually a string, which is quite nice. So one more time, let's go ahead and run that. And we can now see because of this, yeah, it's like, oh, okay, I don't care, that's fine. Yeah, all good. So just to recap, I've shown the action source condition model here. This is a way I kind of devised a good couple of years ago. And if you are struggling with comprehensions, really just try and break them down like this. Comprehensions are something which can be fairly problematic, People tend to kind of stick with for loops because they look easier. You're defining an empty list, you're running a for loop, you're appending to it. A lot of things in Python can be done using comprehensions, and suppose they're not like too complex or too crazy, you can dramatically reduce how much code you're writing. It can look a lot simpler. It can dramatically reduce how much you're writing to please other people, which is also pretty good. So yeah, hope that's helpful, guys. Cheers for watching, and hope you all have a great weekend.